Alarm classification. Not all alarms are created equal. My name is Todd Stauffer. I'm the Director of Alarm Management here at Exeter, involved with alarm management as part of standards development. I'm an editor and voting member of the ISA 18.2 standard, involved in the development of that. I've also been involved in some of the other projects done by that committee, creating technical reports, such as TR1 on alarm philosophy, also the co-chair for the development of technical report number 3 on basic alarm design. And my latest assignment is to be the co-chair for the joint working group between the ISA 84 functional safety team and the ISA 18.2 alarm management team on the topic of safety controls, alarms, and interlocks, which is actually very relevant to this presentation. So first, a little bit about Exida. We're a global supplier of products and services for process safety, cybersecurity, and alarm management. Basically anything that affects the reliability and availability of your control systems. We have tools and processes to help with that. We are one of the industry's leaders in the certification of people, products, and systems. In fact, if you've worked with a safety instrumented system, if you've designed a SIF, put together a SIF, picked out equipment, and looked for things that were maybe SIL 2 or SIL 3 compatible, chances are that the instruments that you're working with, or the devices, were actually certified by Exeter. We've done more certifications and assessments of devices than any other company in the world. We also have a suite of software for SIS engineering and design. That suite is called Excellencia. It includes a couple of different modules. You may be familiar with the Silver tool. It also includes something called SIL Alarm, which is a tool for alarm rationalization, which is the tool that I work with the most. So, what are we going to talk about in this webinar? We're located here in the U.S., so we just had the U.S. elections. One of the topics of discussion there was freedom for all people. The U.S. Constitution says that all men and women are created equal. Well, when it comes to alarms, that's not the case. Not all alarms are created equal. Some are more important than others. Some should get special treatment. Some should be treated more favorably than others. So we will see why one might do that, and what is this process called classification. What are types of classes? We'll address some specific ones, examples, highly managed alarms and safety alarms. We'll talk about how to come up with your own classes, how to perform alarm classification, the benefits of using it, and then also how it shows up in your control system. In other words, what is done with that information. In terms of the key technical references for this presentation, we will be looking at the requirements from the ISA 18.2 standard quite often, the 2016 version. In general, what we'll talk about is also similar to the IEC 62682 standard. In terms of additional information, we'll pull from some of the ISA technical reports. Technical report number 1, which is on alarm philosophy. Technical report 2, which is on identification and rationalization. And technical report number 5, which is on auditing and monitoring and assessment. So with that, why don't we get started looking at classification and some examples in the real world. If you were a monk and in the olden days learning how to make beer, or you make your own beer at home, it was very important to understand the 2 different classes, if you want to call it, of beer yeast. First is called Saccharomyces euvarum, which is bottom fermenting yeast. The second type is called Saccharomyces cerevisiae, which is a top fermenting yeast. And I apologize to any biologists who I've offended by not pronouncing those Latin terms correctly. But the idea is there are 2 different main types of yeasts, and they have very different characteristics in what they like, and thus in the requirements of how you would treat them to make beer. Of course, yeast is what gets combined with sugar to make alcohol, which is what provides the alcohol content for the beer. So lager yeasts, the Saccharomyces euverum, prefer a much colder temperature for fermentation, somewhere between 7 and 10 degrees C, for example, and it takes typically longer for them to ferment. Let's say 4 weeks is their typical fermentation cycle. Ales, on the other hand, ale yeast, totally different type of yeast used to make ales, prefers a bit of a warmer temperature, more like room temperature, 15 to 18 C, something like that. It also has a shorter fermentation cycle, more on the order of 2 weeks. So the whole idea is you have to understand what yeast you're working with, because the environment, the temperature, the length of the fermentation cycle is very different depending upon what type of yeast, the class of the yeast that you're working with. So classification comes into important things like making beer. It also came into the world of process safety. In an example here, a standard was created back in about the year 2000, 2001 called ANSI ISA 91.00.01. And this standard addressed the instruments that are classified, there's that word, as emergency shutdown systems and safety critical controls. And what was the reason for that? What did this standard do? What was its purpose? Well, the situation was that the OSHA PSM, Process Safety Management Regulation, had come out several years before, and process sector owner and operators were actually being cited by OSHA when they were being audited, cited for saying that they're having control systems that were not compliant with the OSHA PSM regulation. At that point, OSHA didn't recognize a difference between the basic process control system or the SIS or the emergency shutdown system. They considered it all as control systems, and that it should all be compliant or meet the requirements of OSHA PSM. So the purpose of this standard was to be able to differentiate, to classify the control system as a BPCS versus an emergency shutdown system, so that only the control systems that were called or treated as emergency shutdown systems would be those that would be reviewed by OSHA and would need to comply with the PSM regulation. So an early usage of classification to help OSHA understand the difference and importance between a BPCS and a safety instrumented system. Another common example that you hear often related to classification: if it walks, talks, or quacks like a duck, then it must be a duck. So on that note, let's move on to some audience participation questions related to classification for alarms. So think about, be interested in knowing how many of you have defined alarm classes in your alarm philosophy document. How many of you have performed alarm classification during the alarm rationalization process? And I mean assigning and documenting what class goes with each alarm. And then the last question is, how many of you have used the highly managed alarm class designation? Typically, when I ask these questions in succession, the number of hands goes down as we move from the first to the third question, typically. So now let's talk about classification for alarm management, where it comes from, what needs to be done, where it's called out in the ISA standard. So in ISA 18.2, there's a concept defined called the alarm management life cycle, which we see here on the left. One of the stages of the alarm management life cycle is called alarm rationalization. This is where we review each alarm to assess its purpose and need and what it's supposed to do for the operator. On the right side here, we see a list of these specific steps that are typically involved in the alarm rationalization process, as defined in the ISA Technical Report number 2 on rationalization. Steps such as documenting the consequence if the operator wouldn't respond, estimating how much time they have to respond, documenting the root cause of the alarm, and then you can see one of the last steps is assigning alarms to a class, or what class the alarm is. So that's a required step in the rationalization process. Now, sometimes to help folks understand what classification is, it's helpful to first understand what it is not. So let's take a look at some things that are not what classification is supposed to be. So it's not assignment based on alarm priority, meaning high, medium, low, critical, emergency, etc. Priority is what the operator uses to know which alarm to respond to first when there's multiple alarms. So priority is for the operator. Classification or class is very different from that. Alarm classification is also not assignment based on the alarm type. So high or high is not a classification, just like absolute alarms versus rate of change versus statistical alarms is not a classification of alarms. Those have to do with the algorithm that essentially runs in the control system to look for and generate and enunciate the alarm when the condition has been reached. Alarm sources, like whether the alarm comes from a PLC or a safety system or a fire and gas system, is not typically also used for classification, although in some cases it may. But generally speaking, alarm classification is not the same as alarm source. And then the last example that I've sometimes seen in practice where classes is used to define, or classes are used as an indicator of what group the alarm is part of, or process area. So it could be part of equipment like mixers or reactors or utilities. You know, that's useful information for grouping purposes, but that's very different from what alarm class or classification is for. So now let's talk about what alarm classification actually is, now that we know what it isn't. It's defined as the process of separating alarms into alarm classes based on common requirements, things like testing, training, monitoring of system performance, and auditing requirements. So testing might be, how frequently are we going to test this alarm? Every year, every month? Does it not need to be tested? Is there no requirements for its testing frequency? So that's a quick example of what we're talking about. Now let's look at another area in real life where classification occurs, and that's in airline travel. If you look at the way airlines handle customers that are in their first class cabin, it's very different from those that are in economy class. First class passengers often get free drinks, food, meals, entertainment. They get on and off the plane first. They have much more room, leg room, power for their computers, etc. Now, why would that be? Well, airlines have analyzed their customers and realized that there's a subset of them which are very loyal business customers that will stick to one airline for all of their air traffic, or for all their air travel. So to reward those loyal business travelers and to make them more loyal because they drive the bottom line of the airline's profitability, they try to put those people in first class when they can so that they can be treated specially and want to continue to fly and be loyal. Now, it's very different from economy class passengers, some of which are people that fly once a year and are looking for the cheapest fare that they can possibly find. Those are not the people that the airlines are making their money off of. So from a business point of view, it makes sense to classify passengers and to treat them separately or differently depending upon that class. So now back to alarms. What does classification use? What is it used for? How does it differentiate? We already talked about testing, so training as well would be another set of requirements that might be different depending upon the class of an alarm. How long the alarm information is retained in history, the frequency of auditing, management of change. So there might be much more rigorous process required for more critical alarms, for example, than those that are just your average process alarm. Reporting and notification, different people getting notice of alarms occurring, for example, maybe somebody from an environmental agency or reporting from a reporting point of view, who needs to know when this alarm goes off, as well as HMI representation and suppression, whether it's shelving or out of service. Now, the ISA standard also defines what should go into an alarm philosophy document. Alarm philosophy is the standards for what you will follow for alarm management at your site. And it's also the first or top stage in the alarm management lifecycle. So ISA 18.2 defines requirements for what content should be included in an alarm philosophy. And you see that listed here. Things like, what is the purpose of the alarm system? How do you do rationalization? And we said rationalization includes classification. There's also specific sections that are focused on classification. One on the definition of alarm classes, meaning what classes will you use, whether you're using highly managed alarms, that's a special class that we'll talk about. And then classification can show itself in other areas of your philosophy document. So it can kind of pervade the whole entire philosophy document and can be a really key element of your alarm management program and making it be successful. So things like performance monitoring, maintenance, testing, training, there might be requirements that are based on alarm class. Typically that's the way it should be done. So based on that, you would see different information in your philosophy in those sections. So also management of change, alarm response procedures, which is a new section, a new required section in the 2016 version of the standard. That has an impact on classification. Alarm shelving may also have an impact or be impacted based on how you choose to do classes. And shelving, the functionality for shelving may be dependent upon the alarms class. Another area where class shows up in the ISA standard is not only is it a part of the rationalization process, but it's a required output of the process. So when you are done rationalization, if somebody was to ever check you or audit you, such as OSHA here in the US, they would look to make sure for each alarm you have documented what its priority is, what its set point is supposed to be, what the operator action is supposed to be when the alarm occurs, what's the consequence that we're trying to avoid, and also the alarm class. So that is a required piece of documentation coming out of rationalization. Now, part of the reason why I'm going through this is alarm class and classification is something that was relatively new in the ISA standard in 2009 when it came out, and there's a lot of practitioners in the industry that don't believe it's worthwhile doing. They don't think it's a good use of time or requirements. And part of what I want to do via this webinar is to show you that that's not the case. Not only is it required to be done, but if it's done correctly and done in the right way, you can receive significant benefit from having your alarms classified and knowing how to optimally treat them. So the results of rationalization are recorded in a master alarm database. Our SIL alarm rationalization tool is an example of that master alarm database. An Excel spreadsheet is also an example of a master alarm database. But the idea is in that master alarm database would be documented the results of rationalization, including the alarm class. Now, class is also mentioned in the requirements discussed around alarm response procedures. What is a response procedure? Well, it's information to provide to the operator, essentially to help them to know how to respond to the alarm. A lot of this information comes out of rationalization. Information like what's the potential causes of the alarm, what's the consequence, what's the operator expected action, and again, the alarm class is expected or recommended to be part of this information that's presented or included in an alarm response procedure. So now let's look at a couple of the examples of types of classes. In the first example set, we have potential classes such as general, which means no specific or special requirements, equipment reliability, product quality, environmental protection, so alarms that are there to prevent violating an environmental permit or having a release to the environment. That would be an example there. Then there's a couple of safety type classes: personnel protection, OSHA PSM critical, LOPA listed, an IPL alarm, essentially an alarm that's identified in a layer protection analysis and is used as an independent protection layer, and then a safety alarm. And we'll talk more about those last two specific classifications, and we'll do a lot of examples in this webinar about LOPA listed alarms. So that's the first approach. A second approach that could be taken is to use examples here such as general alarms requiring periodic training and alarms requiring periodic testing. Now, based on what we've talked about so far, I'd ask you to think about which example set do you think would be more valuable, example 1 or example 2? In my opinion, it's example 1 is much more clearly beneficial to an end user. In fact, example 2, creating a class that's for alarms that require training, is really not what class is all about, since training is actually a characteristic of a class. So creating classes that are based on whether alarms require testing or training, while acceptable according to the standard, is probably not the best way to use classification. So how do you figure out what classes you should have? There's a couple of different approaches. One is to first look at the different sources that define the need for an alarm. Information like a PHA, like a permit to operate from the EPA, Environmental Protection Agency, or from a state or local authority. Those instances would dictate possibly a classification so that those alarms that are called out in that document could be found within your database of thousands of alarms, and to make sure that they're treated appropriately based on the significance. Another way to look at it is alarms that have special requirements when it comes to those characteristics we talked about. So things like training or testing or reporting. If an alarm's got special requirements above and beyond what's typical, then that probably needs to be part of a classification, or you need a class to capture that different requirement. Another way is based on the type of consequence, whether it's a safety, a personnel safety, whether it's environmental, whether it impacts reliability of equipment, whether it impacts product quality. Those are all good potential ways to define classes. And then sometimes it does make sense to use the source of the alarm as a way to create some classes. Again, based on whether the alarms coming from that source all need to be treated a little bit differently. So those are ways to define classes. Here's an example of one and how it might be completely documented. An alarm that's part of a HAZOP that was recognized as a HAZOP but is not used explicitly for risk reduction in an independent protection layer. So we would define a description and also the associated requirements for those alarms. Perhaps this is a more logical way to think about that. We've defined 3 different classes: general, nothing special there; LOPA listed, as I mentioned, alarms that are part of a layer protection analysis; personnel safety, alarms that are there for personnel safety purposes. And you can see that the requirements for how frequently they are tested or operators are trained on them are different. So this is a way to capture those different requirements based on classification. There is a special class talked about in the ISA standard called highly managed alarms, or HMAs. This is an alarm belonging to a class with additional requirements, like regulatory requirements, that are essentially above and beyond what a general process alarm would have. And again, you see there's the general alarm class called out as an example, or specifically. And as part of this definition, there's also an example offered of a safety alarm. So that's another example of a potential classification. Now, in the ISA standard, there are a number of specific requirements that alarms which are classified as highly managed need to follow in areas like shelving, out of service, testing, training, etc. And we'll take a look at that a little bit more in a second. So what is a highly managed alarm? Is that actually a class unto itself? No, it really is not. This is another point that often gets confused. Highly managed alarm is really a designation of a classification. So of the classifications that you have created, one or more or none of them may be designated as highly managed. So it just indicates that there are a specific set of requirements defined in the ISA and IEC standards that must be followed for any alarm class that's designated as highly managed. And if you think about the picture that we see here, this example of an analyzer shed, that alarm working to indicate that there's a low oxygen environment in the shed is really important. If you were to walk into that shed in a scenario where that alarm failed to work, you may never walk out. You could end up dying if that alarm does not work. So certainly the way that alarm is treated from a management of change point of view, you don't want people messing with how that alarm works, that's for sure, because people could get hurt or die if it's not working the way it's supposed to. So also to prove that it's going to work, you may test it very frequently, every week, every month, to test to make sure that that alarm will go off when it's required or when it's needed. Also want to make sure everybody knows when they see that red light blinking, operators and everyone should be trained that you don't go in that shed if that alarm is going off. So in this case, there's an alarm that requires a lot more testing, training, and thought than your average process alarm. But if you think about its importance and what it's for, I would hope that you would agree that it makes sense that those more rigorous requirements should be applied to that particular alarm. So if we thought of it as a highly managed alarm, the alarm for the low oxygen environment, requirements such as this related to initial testing and everything that should be documented, that the operator's response to the alarm is correct, the priority, etc., you would think might make sense for a specific subset of alarms. So the subset of alarms that are classified as highly managed would need to follow these requirements. Now, some people think of these as a burden to have to follow those requirements, as well as these other ones in specific scenarios such as shelving or refresher training. But if you think about that alarm we were just talking about, would you be comfortable knowing that somebody could suppress that alarm and there was not significant management oversight to that? You would not, typically. So there are this extra set of requirements for alarms that are part of highly managed. Now, where did this all come from, or why is it there? Well, the genesis of the concept of highly managed alarms comes from the OSHA PSM regulation. If you thought about having an alarm that was falling under OSHA PSM, and you thought about the requirements that are called out there and what you would need to do to comply with OSHA PSM, that is basically what these requirements represent in the standard. So they represent if an alarm was part of an OSHA PSM program or needed to comply with that, these are the requirements that OSHA would probably expect you to be following. So that's the genesis of the highly managed alarm class and what it was intended to be used for. So now let's look at another special class that's called out in the standard, and that is a safety alarm. So let's start with talking about what a safety alarm is not. It is not the alarm preceding a safety interlock trip. It is not the alarm indicating that a safety interlock has tripped. It's not any alarm designated as a safeguard. It's not also just any alarm designated as an independent protection layer. It's not just any alarm from a safety system, and it's not just any SIS diagnostic alarm. So now that we know what it's not, what is it? Well, a safety alarm or safety-related alarm is an alarm that is classified, there's that word, as critical to process safety or to the protection of human life or the environment. So that's what ISA standard defines a safety alarm as being. Now there's a developing standard called ISA 84.91.03, which I mentioned earlier, which talks about safety controls, alarms, and interlocks and the requirements that must be met for them. And in that it has a definition or a reference to safety alarms, which you can see here. So safety alarms are actually an area where the world of alarm management and process safety or functional safety overlap. So safety alarms need to comply with essentially both the ISA 18.2 standard and relevant requirements from IEC 61511 if there are, or certainly this new standard when it comes out. Now, when we think about what a safety alarm is, it's still a little bit vague as to what it actually means for a running plant. So the whole idea is not every safeguard would be a safety alarm. Some might be, some might turn out to be. Not every alarm that's used as an independent protection layer would be a safety alarm either, because by the definition of an IPL, you could actually have them in your basic process control system, for example. And one probably would not consider those to be safety alarms if they're in your BPCS. So as an end user, it's your judgment is what's called in. You must determine what a safety alarm means or is for your site. So it could be things like, and this is what you might consider, is a fire and gas detection alarm a safety alarm? It's there for mitigation purposes. Is a SIS fault detection alarm a safety alarm? Probably not in general, but maybe there are some related to loss of, availability or redundancy. Those might be safety alarms. SIS bypass functions, are those safety alarms? You'd have to think about whether they really qualify. Partial stroke tests. Loss of key utilities doesn't necessarily sound like a safety situation, but certainly it could lead to problems in your process if you lose your instrument air or your electrical power. Safety instrumented function failures, detection of toxic gases, pH in your effluent to the environment, tank levels themselves could potentially be safety alarms, or as we mentioned, an independent protection layer alarm could potentially be a safety alarm. So safety alarms may have gone through the PHA LOPA process, or they may be defined outside of that, which is why we see the safety alarm figure overlapping IPLs, but also being outside of that box. Now, you would expect that a safety alarm would probably be classified and treated as a highly managed alarm. If we look at the alarms that are on this list, chances are we would want them to meet the requirements that we just talked about, those additional, more stringent requirements. So now we looked at some examples of classes. How do we classify a given alarm? There's a process, and there are four most common approaches. The first being classification based on how the alarm was identified. Second being looking at the consequences and their severity. Third being based on regulatory requirements or policy requirements. And the fourth most common one is based on company policy, such as what you've documented in your alarm philosophy. So let's take a look at a couple of examples. A class called IPL alarms would be for alarms that are identified in a layer protection analysis as an independent protection layer. So that's certainly a valid and useful classification. Environmental could be alarms that are used on the pH of the effluent, could be your NOx levels in your release to your atmosphere, into the atmosphere. Those would be probably related to environmental regulations. Process safety class might be used for alarms that have the consequence of creating a toxic release or a loss of containment, and based on the severity of that consequence might also factor into that. Personnel safety class might be used for any alarm that's part of your fire and gas detection system. And that would typically be something that would probably be defined in your alarm philosophy document. Now, I mentioned that classification is part of the rationalization process. It's one of the steps in the rationalization process. Here you can see a couple of screen captures about how that shows up in our SIL alarm tool, our rationalization tool. So we've got a list of up to 16 classifications that can be defined. An alarm can be assigned to more than one class. To help assess the classification based on the methods that we just talked about, on this screen you are presented with what is the consequence, how bad is the consequence based on your prioritization ranking, where is the alarm identified, the documentation, and if there are any special testing requirements that come out of it as a result of the class or based on where that alarm comes from. For safety alarms in particular, we also would take that a step further and define whether the alarm is being used as a safeguard, and if so, what PHA or HAZOP report or reports call out for the need for the alarm, and whether it's being used as an independent protection layer, essentially a LOPA listed alarm, and what LOPA reports or analysis actually mention that alarm. So essentially creating a cross-reference to where that alarm appears within your safety design. And why would you do that? That would be important because you wouldn't want to go and rationalize away an alarm that's part of a layer protection analysis. That would essentially compromise or change the risk reduction of your plant. Now, one of the benefits of using class, in addition to the general administration of alarms and being able to determine or identify which subset of the alarms require the extra special attention, similar to being part of OSHA PSM, we can also use alarm class to get specific metrics and information on the alarms in those classes from a metric point of view. So thinking about alarms that are used as independent protection layers, those that are defined in a LOPA, we might be interested in seeing the number of times the alarm was activated, percent of time it was active, the number of times it was stale, meaning it was active for more than 24 hours, number of times in percent that the alarm was suppressed or shelved, and the number of times or percent that it was out of service for maintenance. If it's an independent protection layer alarm, you would hope, for example, that it's not out of service or a stale alarm for long periods of time, because that would mean your risk reduction is compromised during those periods. So let's look further at what that means to a LOPA analysis. In this case, we've got an initiating event of a loss of cooling water that we've said occurs, or we predict occurs, once every 2 years. And then we see the different layers of protection that are in place to prevent that from escalating to a fire. One of those layers of protection is the operator response to an alarm, so the IPL alarm. So using class-specific metrics, we can see the frequency of how often that IPL alarm occurs, which means the activation of layer number 2 of our protection layer stack. And what does that mean? That information would be useful in assessing our initiating event frequency. Because, for example, if we've determined that the initiating event should only occur maybe once every 2 years, and we are seeing that the IPL alarm is showing up once every week, that is a much higher frequency. That means that this initiating event is occurring at least once every week, propagating through the first protection layer to the alarm. So very well may be challenging some of the rest of your layers of protection. So being able to create performance or see performance metrics for alarms that are used as IPLs, in this case, would directly help you assess whether your initiating frequencies are appropriate or not, and whether your risk reduction that you've built in is going to meet your tolerable risk criteria. Another thing that you would look at is how much time the alarm is stale, is active. Because essentially if the alarm is active already, it can't re-trigger to indicate that, hey, you have a problem, Mr. Operator, that you need to respond. So the alarm is effectively disabled or not able to work anytime it's in a stale alarm mode. So that would be another thing to look for. The amount of time, again, that the alarm is suppressed, whether it's shelved or out of service, again, represents time where layer number 2 of the IPL stack would not be available. So its probability of failure on demand would be 100% if the alarm was suppressed or during the time the alarm was suppressed. Now these were all specific metrics related to alarms in a certain class. You should also look at metrics from the point of view of, from an overall point of view, if operators are receiving too many alarms, or we have a lot of nuisance alarms, then it's very likely that alarms that I'm counting on operator response to be reliable, like this protection layer number 2 here, are probably going to be compromised. And the operator's reliability will not be what we expected. So the performance metrics, looking at the overall performance, would help us assess whether the reliability of the operator is going to be able to be what it was assumed as. So KPIs and metrics are very useful from that point of view. So now let's look at how alarm class shows up in the control system, in the DCS. More and more control system vendors are building alarm class natively into the control system. Others have it as an optional thing that you can add in, kind of custom, but more and more control systems are making it a true part of the platform. This is an example of a DCS where it is built in. You can see that the alarm classification is actually used within the statistics reporting, as I mentioned, to create a report that shows us the activations for our LOPA listed alarms, so the alarms that are part of a LOPA. It also shows that we can create an alarm summary display to show operators or engineers all of those safety critical alarms that we've said are LOPA listed. So all of our IPL alarms we could see on one single screen. We can also see here that the alarm response information for the operator not only includes information on what to do, but it also includes what the class of the alarm is. So kind of what the purpose of the alarm is so that the operator has that information. So that's one example of how class is used in the DCS. This is another example from a customer where they defined requirements for how IPL or LOPA alarms would be handled. You can see that written here. But what I really wanted to call your attention to was the fact that they wanted these alarms to also be presented differently within the HMI to the operator. So a different graphical symbol. So another area where classification can show up and that the operator would be able to tell differentiate those alarms that are part of that class versus general process alarms. So now kind of bringing us to the end of this webinar and looking at what we've talked about and what we've learned. Alarm classification, despite some in the industry that think it's not a necessary task, that it's not beneficial, it is a required part and piece of information that is defined in the ISA 18.2 and IEC 62682 standard. It is part of the rationalization process. It is required to be done, and the information is required to be documented in your master alarm database. It is used as a way to group alarms that have a common set of requirements, as we said. So alarms that need to be tested very frequently or that the operator needs to be trained on every year. That's one of the key things that we use classification for. Now, I would recommend thinking about what classes, when you are defining your classes, create those that will help create the most benefit for you. So from understanding what alarms must comply with different regulations, must be reported to different people, create the classes in a way that not only helps you administer and maintain the alarms appropriately with the right level of effort, but also allows you to get the most benefit from analyzing and understanding what's happening. And then last but not least, we talked about the special classes that are mentioned in the ISA standard. Highly managed alarms. Those are the alarms that are essentially, or that's the designation that's applied to classes. So it's not a class itself, it's applied to classes to indicate that those alarms must meet a predefined set of requirements. And as we mentioned, kind of originated from the idea of what you would need to do to comply with OSHA PSM. We also talked about safety alarms, what they're used for, what they mean, and that's something that I would certainly, as the ISA 84.91.03 standard moves forward, you'll see a lot more about safety alarms, what they actually mean, and what is required. Again, as kind of the intersection of functional safety and alarm management, safety alarms will need to be treated in a way that complies with both of those disciplines. So that kind of draws us to the end here. So I will say thank you for attending. If you enjoyed this webinar on alarm management, I'd encourage you to check out some of the others that we've recorded and posted on our website previously. The link is there. There's also information on my email address. If you have any questions that this webinar prompted, please feel free to shoot me a email about it. And let's see, questions. There is one question: what is the difference between a safety alarm and an IPL alarm? I don't know when that actually showed, or when that question came in, but I think it was addressed when we looked at the figure that showed safeguard alarms and IPL alarms and safety alarms. So safety alarms is a more discrete set of alarms than IPL alarms. So some IPL alarms could be treated as safety alarms. It depends, essentially how important they are. One other way you would judge might be based on where those alarms come from. If it's an IPL alarm in your BPCS, chances are it's not that important that it should be a safety alarm. If it's a safety alarm, that alarm probably either needs to be part of in your SIS, or at least be in a dedicated system that has or uses high reliability hardware similar to what an SIS would. So there's also one question or comment about the presentation. Since you've all attended this, you'll get an email that provides a link to where the recording and the presentation will be. So you'll be able to get a copy of this later. And I guess that's it for questions. So with that, again, I will say thank you very much. Appreciate you joining this Exeter webinar, and hope that you will tune in again soon to hear some more webinars from Exeter. Thank you.